Hi, everyone. Welcome to class. Welcome to whenever you're watching this. I mean, I hope you're watching in class. If you're watching after class, it means you didn't do your work. I don't love to hear that. First day of the unit, it's about moving on to conic sections, which literally just means things like conic meaning cone, where you intersect a cone. Uh, Day one, about circles, completing the square, hopefully things that you've seen before in geometry. If maybe you don't remember completing the square, or you haven't seen completing the square, circles, I would feel very confident that you've done before. So there's your warm-up. Go ahead and do your warm-up. And just give yourself like 4 minutes. So go ahead and pause the video. And hopefully now you're unpausing, or if not, you can pause it now. Okay. Hopefully you're done with the warm-up. Hopefully you use the pause button. So now we'll check what you did against. I'm going to put up branches for the green and the yellow. Not necessarily going to talk about the red in this particular video. We can talk about it in class. For the green, identify the domain and range of the circle, x plus 2 squared plus y minus 5 squared equals 9, and also graph the circle. You can do that in kind of any order. I'm going to go with domain and range first, just to show that you don't necessarily need a graph to get this done. If you remember from geometry, this is an equation of a circle where the center is -2, 5. All right, so I've got an x plus 2 that's telling me that my x coordinate for the center is -2. I have a y minus 5, and that tells me that we're going to have a positive 5 as the y coordinate for the center. Right, and the radius would be 3. Right, the radius squared being 9, so 3 squared gets you to 9. All right, so based on that, the fact that I have the center and the radius, I can figure out the domain. Because the circle centered at -2 will only go basically as low as -5 if the radius is 3. Right, so I would say -5 is the lower bound of this domain. And then going in the other direction, if we have a circle centered at -2, radius of 3, I would think that the upper bound, the maximum x value would be 1. Right, and because I do expect the circle to include these points, and we can verify this later when we graph the circle, but I'm going to use brackets as opposed to parentheses. And so similar thing with range. So the center of the circle is at a y value of 5, right? We'll go as low as 2 if the radius is 3, right? So center at 5, and then lowering by 3 goes down to 2, and then as high as 8. Right, and so another thing about that, if I put the center of the circle at -2, 5, so right here, right? And I know that the circle should have a radius of 3 upwards, downwards, left, and right. Right, then I basically constrained the circle to be, in terms of domain, as low as -5, as high as 1, but not beyond that interval. And then for range, as low as 2, as high as 8, but again, not beyond that range. Right, so that would be the way I would graph that circle. If you really want to be technical, you would take out the point in the center, because the point in the center is not part of the circle. But, you leave it in. It's not the worst thing in the world. We'll come on to yellow over here. So write an equation for a circle that has a diameter with endpoints 2, 5 and -2, -1. Right, so I'm just gonna do a quick little sketch of the circle here. I'm gonna draw on some axes. So 2, 5 and -2, -1. Right, and we have a diameter of the circle running between those 2 points. And the actual circle itself would be about there. All right. So if I'm going to write an equation for this circle, I would want to know the center and I would want to know the radius. And then we can just sort of use the same structure as used in the previous problem. In terms of finding the center, if you're thinking, oh, why don't I just sort of eyeball it here? I mean, maybe even if you had like, a nice grid that you actually had everything like accurately measured out to, you sort of eyeball it. I would say definitely didn't do that here. So I wouldn't feel comfortable doing that. But also, I think we can just, find the midpoint of these two endpoints, right? If these 2 points are the endpoints of the diameter, the center of the circle should be the midpoint of that diameter. All right, so I'm just going to find the midpoint there. The average of -2 and 2 is 0. I guess I'll make the point a little bigger. And then the average of -1 and 5 would be 2. So I would feel comfortable saying the center is at 0, 2. And basically just averaging the x values and then averaging the y values, and that would give me the midpoint exactly in between. All right, and then now we'll need to find the radius. You could use distance formula if you were so inclined. Me personally, I would prefer to use Pythagorean theorem. And so in that regard, I would say that this segment has a length of 2, right? Because we're going from the x-coordinate of 0 to the x-coordinate of 2. And then this vertical segment has a length of 3, right? Because we're going from a y value of 2 to a y value of 5, right? So 3 and 2. And my radius of the circle is just going to be this segment here. So using Pythagorean theorem, 2 squared plus 3 squared is equal to the radius squared. 4 plus 9 is equal to r squared. 13 is equal to r squared. You could square root and say that the radius is root 13. Perfectly fine. But because you were asked for the equation, I'm just kind of going to stop here and just throw this equation together. Because the equation would actually use r squared as the constant on the right-hand side. Right, so the same way that over here, when the radius was 3, the constant for the equation was 9, it'd be the same thing, right? I could find the radius as root 13, but I'm going to end up squaring the root 13 to finish off my equation. So I would say this is where I want to end things. Right, so there's a lot of geometry that was baked into that first page, right? We did some midpoint stuff, we did some distance stuff, and most crucially, we talked about the representations of circles, both as graphs and as equations. In case that particular part was rusty, right? You can refer to this section down here, right? Don't have to get into necessarily the definition of a circle. If you're rusty on it, please read the definition and get that down, but I'm going to trust that you sort of have that down. This blue panel is sort of indicating what I had alluded to earlier. When you talk about conic sections, we're talking about literally the intersection of a cone. So you see that the plane just sort of cuts directly across the cone, and then that intersection, or the set of points for the intersection, basically creates a circle. And then in terms of what we're going to have to be able to do for representing circles, right? This is the main representation that you really got to be familiar with. We call this a standard form equation. Unlike standard form polynomials, standard form conics have a lot more parentheses involved. But basically this is what we talked about. If you have a center HK and a radius R, right, then you would use those values to generate the equation for the circle. X minus h squared plus y minus k squared is equal to r squared. right? So we could give you that information, ask you to write an equation. We could give you the equation. You have to pull out the information and then make the graph. We could give you a graph. You have to find the information, then put that into the equation. You just got to be ready to go and move between all of the different representations. Very similar to how we did with polynomials and trig and all that stuff. All right. And then there will be a general form equation. We'll talk about that in a little bit. But basically, if you were to take both of your squared binomials and expand out and then combine all of your like terms, you would end up with an equation that looks like this, right? And that's what we call a general form equation. We'll talk about that in a little bit. All right, let's I'll do number 1 with you together, and I'll have you do a problem on your own, and then we'll do number 3 together. So number 1, circle A has a center of -2, 1 and a radius of 5. Identify the domain and range. And again, you can do this before you graph. In some ways, it's actually maybe better if you find domain and range before you graph, because that way, you won't be tricked by your lion eyes if you graph the circle incorrectly and then your domain and range is wrong. We can just do a little arithmetic here. So, for example, -2 minus 5 would be -7, and -2 plus 5 would be 3. Right? So I'm just going from the center and moving left 5 and right 5, and that gets me -7 and 3. Right? If the center has a y value of 1, the lower bound should be 5 below 1. So 1 minus 5, -4. 1 plus 5 is 6. Right? So just down 5 and then up 5. And that establishes my range. Right? If we have a center at -2, 1, that'd be right about here. Radius of 5 means that I want a point that is 1, 2, 3, 4, 5 units above that center, and 1, 2, 3, 4, 5 units below the center, 5 units to the left, and 5 units to the right. Notability is nice because it will just draw the circle for you. Suppose on a test you should get used to trying to freehand those curves. Or bring a compass. Do you own a compass? Not like a north, south, east, west compass, but like, a compass. I assume you used a compass in geometry. But I guess I shouldn't assume things. I don't know. Excuse me. All right. So let's refer back to our notes up here. We said that if you have the center HK, you want x minus h in the first parenthetical binomial expression. So given that our h value is -2, if I'm subtracting -2, I would want an x plus 2. Right, then we said y minus k, and we have a k value of 1 here. So y minus 1, and then we want r squared, and our radius value is 5. So I'm going to square 5 and get 25, and there's our equation. Hope things are going well out there. Hope we're hanging in there. Why don't you try it too? You can go ahead and pause the video. You try it with a teammate, talk to someone next to you. Problem solve a little bit. I think we know all these words. We know tangent. We talked about tangencies. Not like tangent values, but like tangent to a line, to a curve. We talked about x-intercepts. Just go ahead and try it. Try it out. Pause the video. You pause the video? Are you unpausing the video? If you're unpausing the video, we can move on. But if you haven't paused once, pause the video. Okay. All right, I'm gonna assume you're done with 2. I'm assuming that you tried to. Did you try to? Did I try to do what? Never mind. A circle B is tangent to the y-axis at 0, 3. That's probably an important point. I'm going to mark the point 0, 3. Has x-intercepts at -1, 0 and -9, 0. All right. So just to recap, in the context of circles, if we were talking about tangency, right, that would mean that there's a line that touches a curve exactly at one point, right? And that's exactly what we have here. I can honestly draw an inference that because the circle is symmetric, I'm going to have another point over here, right? Because if this is a point of tangency, then the line or the segment that is perpendicular to that tangent line, in this case, the y-axis is a tangent line, right? That should be a radius of the circle, which means if I extend that horizontal line, that should be a diameter of the circle. And so at some point I hit the center, but then the center would have to be exactly between these 2 points at an x value of -5. So I feel like we can draw the conclusion that our center is at -5, 3, and then I'll just reflect this blue point over the center, or rotate around the center, and get to this purple point over here. And now I can just boom. On the graph, shablam. See, and look, it goes exactly right through the 2 points that we wanted. You'll love to see it. And I suppose this does sort of, this all hinges on whether you can remember things from geometry. And I say that, and then someone just reacted like, I definitely don't remember things from geometry. And that's a real shame. That makes me sad. Are you gonna remember things from pre-calc after you leave pre-calc? Or are you gonna forget all the things from pre-calc when you go to calc? You better not. Do you embarrass me in front of your calc teacher? Swear to God. Write an equation representing circle B. X plus 5 squared y minus 3 squared is equal to 25. What if this video is muted? Just had the thought. Oh, good, it's not muted. If I had just been sitting here for like 10 minutes trying to record a video and it was muted, that would have been rough. Anyway, the center was at -5, 3. That's why I put x plus 5 and y minus 3. The radius is 5, that's why I put 25. There's our equation. Hope we're still hanging in there. All right, let's move. Let's do 3. Now I won't make you try 3 on your own, unless you want to. Do you want to? You want to? Have at it. Try it. I encourage you to try new things. Said graph the circle represented by the equation bloppity bloppity blue. Don't reach for your calculator. Don't reach for Desmos. I feel like some of you weren't, and then I said that, and now you're going to, which is a real shame. Oh, someone's trying to. Oh, Miss Trant's about to walk in. She's gonna walk in. I'm recording a video. You can come in. Hi, Miss Trant. I'm recording a video because I'm gonna be out on the 29th. TBD if I'm gonna edit this part out, but you can come be on camera. Is Lishka here now? Lishka's in here. You're like looking at me do like circles, and you're like, "What the hell is he doing?" There we go. There's Miss Trant. All right, I'll try my hardest. Bye. Anyway. I mean, you'll know if I edited that out, but I'm not gonna edit it out. That's too much friggin' work. Here are the steps to completing the square. We're gonna do a process called completing the square. Completing the square. All right, number 1. We're gonna move the constant from the left to the right. What I mean by constant, I mean literally this term that has no variables attached. It's just the number 20, right? Constant value because there's no variable attached. So 1, move the constant from the left to the right. And so here that would mean that we have x squared plus y squared plus 4x minus 10y is equal to -20, right? Just subtracting 20 from the left to the right. 2, separate the variables. Technically, you don't need to do this, but oh my God, does it help? I strongly recommend. And if you heard me say that you don't need to do something, like, cool, all right, bet, I won't do it then. Like, I think you're missing what I'm saying. Anyway, notice how I had x squared, y squared, x and y, but now I'm separating those into just the x's and just the y's, right? You really want to separate those variables because we're going to be working sort of just with the x's for a little bit and then just with the y's. So regrouping does help, right? After you have regrouped those variables number 3, we are going to find the missing constants. Not constants like a woman's name, but like constant, plural. All right, what I mean by that is that it is possible for us to add a specific number right here such that everything in the purple box becomes a square, right? I'd have a binomial and that would be squared, right? I'd have x plus some number and that whole thing would be squared, right? The question is, what do we want this number to be and what constant should we be adding to the line above, right? Some of you may see this already and you're like, oh, it's x plus 2 squared, easy peasy. Just in case you don't see that, I'm gonna just draw a little bit here and we can see sort of how we can use the area model, everyone's favorite, the area model, the box model, to get more of this going. So for example, right, what I have right now is an x squared and also a 4x. But if I know, basically, I'm going to break out more geometry notation, that this entire diagram literally needs to be a square, like the same side lengths vertically and horizontally. That would mean that these two sections of the area model need to be the same, right? They need to have the same area. Otherwise, the overall diagram is not a square because the lengths would be different. So in that regard, this 4x that I normally split between these two sections needs to be split evenly between the two sections, which would tell me that I would want a 2x here and a 2x there. Right? So I have x, and then this is where we're going to find some of our missing numbers in terms of what's happening over here. Plus 2 and plus 2, but more crucially, plus 4. Right? That's the missing constant that makes this a squared binomial. If I just had x squared plus 4x and I didn't have the plus 4 right after, I definitely wouldn't say that that was equal to x plus 2 squared. That would just be x GCF times x plus 4, right? So we're trying to locate what is the number that goes here to make our squared binomial, helps us find the center of the circle. But also you have to make sure that you are accounting for that in the line above by adding the correct constant, finding the missing constant that you're going to add in, because that needs to be added on the left and the right, right? Whatever you do on one side of the equation, you must do on the other side as well. So because we are adding in a 4 on the left that was not present before, we have to add that 4 on the right as well, all right? Effectively, I'm going to add that to the notes down here. Find the missing constants, comma, add to the left and right. Right. And so based on that, if I slide this over here, can you, at this moment, try to duplicate that process and figure out what is the missing constant that we need to add in on line 2, right? And what will that give us in terms of a squared binomial down below? Try that for a moment. All right, here comes your answer. The -10, if we split evenly, is going to give me a -5, and this should match up if you're doing the area model, right? Or if not, you can sort of do this in your head, no big deal. And then that -5 squared means that I would have wanted a plus 25 up here, right? Otherwise, the quadratic wouldn't have been factorable. Let's change up this color. Let's make this turquoise. So that's basically the process of completing the square. And then we just have to simplify on the right. So -20 plus 4 plus 25 would have been, I don't know why I wrote negative, +9. 29 minus 20. 20. Yeah, 29 minus 20. 9. So I kind of got all up in my space for where I need to put the circle. This is my mistake. I should have made this so that the circle goes in quadrant 4. See, because look, now there's like no good place to put this thing. I can drop that there. But the circle will be centered at -2, 5 with a radius of 3. Right, and there's a circle. All right, so just to recap, we went over some stuff from geometry, right? Can you read an equation and get the key features of the circle? Can you use those key features to graph a circle, right? We did a little bit more just in terms of graphing and also in terms of writing, right? So basically, if you can generate the graph of a circle, can you pull out the key features to make an equation? And we also talked about completing the square. All right, so rewatch any part of that video that you need to. And when you're good, start working on the Unit 7 IP01. So I expect everyone by the end of class to get like, some portion of that done, minimum one problem. But I would hope that you could crush out a whole bunch of those problems and really be productive. All right, so I will see you tomorrow.